Hi everyone, welcome to the periodic table revision math that we're going to complete now. So let's start off right on the right hand side. So how did Mendeleev order elements in his original periodic table? So he put them in order of increasing atomic mass. So we don't do that anymore. In fact, we order the periodic table by increasing atomic number rather than atomic mass, because there's a few issues that are raised if you use increasing atomic mass instead. So some are kind of not in the right order in comparison to the patterns that they have in the periodic table via groups and periods. So that's why we no longer use that. But Mendeleev did use increasing atomic mass when he first put the periodic table together, which is obviously revolutionary at the time. So he left gaps because there were some elements that had not yet been discovered, but he used his periodic table to predict the properties of the elements that had not yet been discovered, which is, again, pretty awesome, or very awesome, to be honest with you. So he leaves gaps for elements yet to be discovered. So when I say yet to be discovered at the time when he produced the periodic table. Amazing. Okay, so on the periodic table below, identify each group using numbers. So the group numbers are the ones on the top. So we've got group 1, 2, 3, 4, 5, 6, 7, and 0 or 8 along the top. So we've done that one. Identify each period using numbers. So period is down the side here. So we've got 1, 2, 3, 4, 5, 6, and 7. So we've done that. Identify the metals, colour in using a colour of your choice. So we've got a like a step that goes along here in the periodic table. I'm just going to put that down with my pen just to do the outline. So that separates the metals from the non-metals. So metals are over this side, and then the non-metals are over this side. So I'm going to use two different colours. I've got pink for the non-metals. I'm just going to shade it in quickly. Just over here. Okay. So these are all non-metals, and on this side, these are all metals. I'm going to turn it sideways to colour in, that might be easier. Got a squeaky pencil. It's been quite a while since I've done colouring in. So everything found on this side of the periodic table, the left-hand side, are metals. These ones in the middle without a group number, they're called the transition metals. And then we have that link. You've actually got metalloids that are found in here as well, but we don't need to know too much about those. So we're just going to leave that for now. Okay. So the metals are there, non-metals are there. So we've done those two up there as well. Brilliant. Nicely labelled. Let's have a look over here. So where is the element below found in the periodic table, group and period number? So there are lots of patterns in the periodic table. So we've already identified the group and the period, and the metals are on the left and non-metals on the right. But we can also have a look at this. So here we've got two electron shells, so it must be in period 2. Okay, because there are 2 electron shells. So the periods equals number of electron shells. So it's in period 2, so it's one of these along here. Okay, all the way along. And then we look at the number of electrons in the outer shell. There are 2, so it's in group 2. That's 2 electrons in outer shell equals group 2. So it's in period 2 on here, group 2, so it's actually this one here, so I'm going to put a little star. So if I then bring in my periodic table, if I go period 2, which is here, group 2, so remember that's period 1 with hydrogen, it's just moved over a little bit here. Period 2, group 2 is beryllium Be. So I might just write in here beryllium Be, just so I can remember what it is. Okay, so next one then. So remember, key thing, remember electronic configuration is 2882. So using the periodic table, draw the electronic configuration for the following elements. So carbon. So I'm going to find carbon on here. So carbon is just here. It is in group 4, period 2. So I'm going to write down group 4. So that's 4 electrons in outer shell. Period 2. So 2 shells. So these are all my notes to help me. And then we're going to look at the atomic number, which is 6. So there are 6 electrons. So atomic number equals 6 electrons. Okay, so I'm going to use my pencil for this. I'm going to write carbon, which is C, so I'm going to write that there. I know there are 2 shells, so I'm going to do my best to do 2 quite even looking circles. I know there are 2 shells, that's that one. There are 4 electrons in the outer shell, so 1, 2, 3, 4, 6 in total, and I have to put 2 in the first one, so there's 2 there, I'll put 2 there. Just going to double check. So 4 electrons in the outer shell. Yes, 6 electrons. 1, 2, 6 electrons in total. So that has electronic configuration 2.4. 2 in the first, 4 in the second. 2 add 4 is 6. Excellent. So I know I've got that right. I'm then going to repeat that for phosphorus and lithium. Okay, so let's find phosphorus is here. So it's in group 5, period 3. So group 5, period 3, and the atomic number is 15. Atomic number 15. So I'm just going to add my notes here. 5 shells, 3 electrons on outer shell. So I'm just using E minus because electron for E, minus it's a negative charge. Atomic number 15, so 15 electrons. So let's start doing this. So phosphorus, my symbol, let me just remember, my symbol is P. Has 5 shells, no. Oh my goodness, I've got it the wrong way around, haven't I? So this is where I can double check. It's not 5 shells, it's 5 electrons in the outer shell. 3 shells, and the atomic number is 15. So you can see, actually, I've self-corrected straight away there. I've realised I've made an error. I was thinking, why am I drawing 5 shells? I've never had to do that before. That's given me a hint. We look on here, we've got maximum 4 shells. So I've worked out that I've got it wrong. So P, and then I've got 3 shells. 1, 2, 3 shells. Oh dear, a bit wiggly. So 5 electrons in the outer shell. So 1, 2, 3, 4, 5. I have to have 2 in the first, and you can see over there 8 would be in the second. So 1, 2, 3, 4, 5, 6, 7, 8. So it would be 2.8.5. Let me just add that up. 2 plus 8 is 10 plus 5 is 15. So yeah, brilliant. I've got that correct. Let's try lithium. Hopefully we won't make the same mistake again. So lithium, here we go. Lithium, group 1, period 2. So group 1, period 2. And the atomic number is 3. So atomic number 3. So let's just make sure I don't make the same mistake again. So group 1 means 1 electron in outer shell. Period 2 means 2 shells. Right, just double check. Yep, I've got that right this time for you. So here we go, lithium, Li, it's got 2 shells, 2 circles, 1, 2. Oh, I keep hitting the camera, I apologise. And then 1 electron in the outer shell, and it has to have 2 in the inner one. So that's 2.1, 2 add 1 is 3, there's 3 in there, excellent. So I know that I've got it right. So there we go, that's the periodic table revision sheet complete.